Hello, thank you for the opportunity. Happy to be here. I'm very honored to show our project. Um, well, um, in the start, I want to ask something that you may ask yourself already, and this is the reason why we are here together. And I wonder if you ever felt while you were sending a message to a family member or a colleague, or sharing a picture, whether this picture is only seen by your colleague or by your family member, or also by the owner of the company. For example, in my case, every time I share any personal information, I don't know, for example, bank account on WhatsApp, I have the feeling that I'm sharing it with Mark Zuckerberg as well, and uh, and it's something that I don't really like. It's I'm talking about Meta, but there are another big tech companies that they make a very big impact in how we are controlled regarding the information and how they monitor our data and so on and so forth. And Waku is the main purpose of Waku is to tackle this flow of information and bring power to people in terms of controlling their own data and their own information. Okay, this is me. I work as a protocol engineer at Waku. There you have my contact. I'm happy to help if you have any doubt. But let's jump to the interesting stuff. Um, First of all, the agenda. We're going to see why Waku, what is Waku for. We're going to cover the protocols about Waku. We're going to learn about the main protocols that give privacy and censorship resilience to the network. And regarding this topic, we are going to talk about Gossip App and RLM. And then we're going to see Waku use cases, integrations, and the roadmap for the Waku project during this year. Okay, why Waku? Well, the history, as you know, in 2013, Dr. Gavin Woods created the term Web3, and he envisioned a change, a movement in the internet that we know nowadays, and he created the Ethereum with the help of Vitalik Buterin, and Swarm and Whisper. And I'm highlighting Whisper in this case because Whisper somehow represents the origin of Waco. And until 2020, the status application, for those that you don't know, this application is multi-feature application that allows messaging, private messaging, wallet, and Web3 browser. They started working on the top of Whisper, but they found that for any reason there was some kind of lack of maintenance, and they needed to have an improvement in terms of resource restricted devices. And the thing is that Whisper on that time they used Flood SAP, and to get an idea of what Flood SAP is a way of giving privacy in the communication, but broadcasting messages. But that was very good solution indeed, but it has a very big problem that for resource restricted devices was very battery consuming, and for smartphones, and with a lot of data consumption. And then for that reason, Waku was created as a side project and with the aim of enhancing the problems that the status app needed to incorporate. And okay, in this slide, what is Waku for? is basically and essentially to communicate privately, and is permissionless in the sense that anyone can participate in the network, anyone can run a node, anyone can submit a PR. We are open source, and we have Discord channels, Discord servers, and anyone can join and ask for information. It's private and secure in the sense that the protocols that we have implemented provides privacy and secure, because all the communication between nodes is encrypted, and of course is decentralized. And something very important is that the Waku project is going to bring an off-chain communication. It's not directly related to on-chain, to a blockchain. Okay, let's carry on by the protocols. We have three or four main sets of protocols. The first one is the discovery ones, that they allow nodes, once they join the network, to discover another nodes, and then start participating in the communication. Then we have request response nodes, and these are interesting for the sake of resource restricted devices where they cannot participate so heavily in the gossip sub, and so on and so forth. And then we have message routing, the relay gossip sub, which is very important, and we're going to step further in a minute. And for spam protection, we have RLN. And it's very important to bear in mind that, given that this decentralized network that is not owned by anyone but by the community, it needs a mechanism to protect itself from spamming. And for that reason, we've created the RLN spam protection. Okay, regarding the discovery methods that we have at the moment, there are three main types of discovery. We have the peer exchange, which is very simple, and it basically says, imagine node A asks node B, hey, please inform me about the peers that you are connected to, and potentially I will connect to them as well. Then we have the DNS-based discovery, which is very similar to the peer exchange, but instead of asking to another peer, the node asks to a DNS server. These two protocols are interesting, but they have the drawback that are pretty centralized, and for that reason, we consider that the Discovery v5 protocol is much more important. And the basic idea of the Discovery v5 is the same. One node, once joins the network, this node needs to discover another peers, but instead of asking to a particular node, this node asks to distributed hash table, which is represented by a distributed network of nodes. And this is, from our point of view, much more robust and decentralized, and is our preferable method of discovering. And also, let me mention that the implementation is based on the actual Kademlem implementation back in 2002, I think. But the only difference is that we advertise the protocols any node is supporting. And okay, then we have the request response protocols. Regarding the store protocol, for you to get an idea, the Waku network, it distributes messages across the network. And it exists churn in the network, in the sense that there are nodes that are continuously leaving the network and joining the network. And for that reason, we need some kind of temporary storage of these messages, so that when a node joins the network, this node can get the latest status of the messages, and this is the purpose of the store. And then we have light push and filter, and these two methods, these two protocols, sorry, are very important in order to allow the participation in the network to resource-restricted devices. I'm talking about web browsers and smartphones. And these light push and filter protocols are very important because they cannot, the resource-restricted devices cannot directly participate in the gossips app, which is, from our point of view, or my point of view, is the most important protocol in our stack, and is where magic happens, and thanks to it, we can provide privacy to the communication, and we're going to go deeper in this protocol. Okay, something important to me is that to make it understandable how the gossips app works. Let's imagine that we have this network, super connected nodes, and all of them are continuously sending gossip control messages. By control messages, I mean all the nodes are asking each other, "Hey, I have seen this message. Which messages have you seen? Can you send me these ones?" And they are continuously gossiping. And then we have the mesh, and the mesh is represented by the green connection. What does a mesh represent? It represents the actual flow of data, of information. But this mesh is not random. This mesh is measured are built by the network itself. Each node creates or selects the best nodes among its neighbors. Then the node analyzes its neighbors and gives a peer score or about each of them, and the best neighbors gives the chance of communicate actual data. And this the peer scoring is where the mesh calculation is needed. Every node is continuously measuring and analyzing its neighbors, and that happens every second. Every second, every peer has a picture about how other peers in the surrounding behaves. And it's important to bear in mind that the actual communication happens only for those peers with peer score greater than 0, but not beyond that, because, aside from that, it's important to bear in mind the amplification factor, which we have it configured from 4 to 8, and what does it means is that each node can only potentially relay to this number of other nodes, and this is a way to restrict the bandwidth used by any of those. And to get a better idea about how the peer scoring works, I think is to see an example. This is a very simplified example, and in this case, what we have is that node A has this peer score about these neighbors, and one message comes in and only is resent to these ones. In this case, it's very simplified, and the amplification factor is set to 2, but we normally have amplification factor between 4 and 8. Okay, and this is a very important feature, the RLN rate limiting nullifier, and this is very, very interesting and with very theory behind it, and it's beyond my knowledge, but I could tell that it helps the network to be protected against the spam, and it gets the protection thanks to the zero knowledge snark, and by zero knowledge it means succinct non-interactive argument of knowledge. That means that the proofs are very small, and with that they can prove that a publisher can prove that he or she belongs to a certain membership set. This is actually the only interaction with a smart contract, because for the case of in order to participate in the Waku network, actually the Waku network is an opinionated way of participating in the Waku network. It doesn't mean that it's owned by us. Instead, what we are willing to do is something that is owned by the community, and is self-sustained by the community itself. And in order to participate in the Waku network, any member needs to take a registration, and the registration is made on chain. And then once this registration is made, in order to publish messages, then this technology allows these messages to be published and to enter in the network. Okay, regarding the Waku use cases, well, it's very simple. You can imagine everywhere where your project needs privacy and censorship resilience. In communication, yeah, these are the actual use cases, and the idea is that the communication is off chain and can help to reduce costs, because many communication on chain has underlying costs. And let's talk about current integrations of Waku. As I mentioned earlier on, the origin of Waku, it comes from Status, and actually we belong to the same organization, which is Institute of Free Technology, and the Status application, as I mentioned before, is multi-feature application that allows messaging between contacts, allow to store private keys, behaving as a wallet, and also a Web3 browser. And then we have Railgun, and this is a very interesting project as well. I think it was actually mentioned last day by Vitalik Buterin, and I think it's very interesting regarding privacy. Because this project allows to bring privacy in blockchain transactions, and the way it works is that in this project, the Waku network or the Waku project helps them to communicate wallets with their relayers in a private way and censorship resilience way. Then we have XMTP, and XMTP also uses Waku, but they are not open source, and they are more centralized, and I cannot mention much more about them because we don't know exactly how they integrate us. But as I've seen from their documentation, they use Waku to communicate their backend servers. And then we have the Graph, which is a very interesting project as well, and I strongly recommend to take a look. The purpose of the Graph is to help another projects or applications to easily retrieve information from blockchains. As you know, is difficult to extract the information from them, from the blockchains. The graph has a network of indexers, and the Waku is helping them to synchronize these indexers. Okay, and aside from that, how to integrate Waku? Well, it can be integrated everywhere as a desktop application, smartphone, and Raspberry Pi, and much more. We know that it's a bit complicated to integrate it, and for that reason we have a Discord server, and we are more than happy to help if anyone would be interested in integrating the server. And the idea is, if you need to communicate your users in a private way, then you can contact us, and we can help to do so, and we are more than happy to attend you. And another way to participate in the network is by joining the Waku network, as I mentioned earlier on. And that doesn't mean that this network is owned by us, but you can run your node, and at the moment we have more than 400 nodes running, and they are running, as I mentioned before. The registration needs to be made in a blockchain, and the current registration is made in Sepolia. Okay, and this is the roadmap for this year. We're going to replace Go Waku to NIM Waku in the status app. Regarding our tech stack, one of the major programs or languages that we use is NIM and TypeScript. But Golang is very important for us as well. But we are going to invest more efforts in NIM, and for that reason we are moving the Go Waku into NWaku. Then another very important project or feature that we are going to implement this year is the store sync protocol. And as I mentioned earlier on, we have a bunch of nodes that they store messages, and these messages that are stored, they help nodes that join the network to be on shape, I would say. And the store sync is a very interesting protocol that is going to help to synchronize the data within the store nodes, so that all of them have the same state. And then we have RLN v2, which is going to limit. This is going to help us limit the number of messages per second, because at the moment it's a bit poor, the control, and it only allows one message per second. And with this feature, is going to make it easier to control the rate the applications can publish into the network. And very important, this point is to simplify the SDK. We are aiming to make a very easy SDK that can be integrated in almost everywhere, and just publish, subscribe to a particular topic, desubscribe, and send, and that's it. And we are going to extend the operability. We are willing to make the Waku nodes to be easily to be integrable in Node.js, Rust, Golang, and React Native. And also very important, our team is growing at the moment. So if you are interested in joining our project or whatever, we are more than happy to learn from your thoughts. The project is very cool, and I can swear that all my colleagues are much more smarter than me, and yeah, I'm very proud of them. And as a summary, before ending the presentation, I would like you at least to remember 3 concepts. First of all, Waku. Second, gossip sub, and rate limit nullifier. And yeah, and that's it. I think if you have any questions, thank you so much for your time.
Round of applause for Ivan, please.
Thank you.
Questions? One question in the corner.
What's the purpose of nullifier in the context of Waku?
Well, this the purpose is to control the rate, the maximum rate any publisher can publish messages to the network. It's, yeah, I would say this is the
Follow-up.
Yeah, and is it implemented the same way in every language, computer programming language? Yeah.
Say again, sorry.
So you're probably you have a roadmap, right? Where you're probably going to implement Rust, React Native, right? Is it implemented the same way in every programming language?
Well, actually, we have what we do is the implementation of the proofs and the verifier. This is made by a Rust library, and we use ZeroKit. We use ZeroKit, which is a project that allows to interact with CK circuits, and is always implemented in Rust, but we integrate it in NIM or Golang or.
Any other questions? One more round of applause for Ivan, please.
Thank you.